Welcome to the deep dive. Today, we're really getting into creatine. Now, this molecule, it's got this huge reputation in fitness circles.
Absolutely legendary.
But what's fascinating, and what the research really points to, is its fundamental role that goes way beyond just lifting weights. It's essential for, well, basically all high-energy tissues in your body.
That's the key thing we want you to take away today. Try to forget that bodybuilder image for a second. Creatine is probably one of the most studied substances in sports nutrition. We're talking decades of solid data.
So much research.
Exactly. So our mission here is to cut through all the marketing hype, and look at the actual science. What does it really do for performance, for recovery, and maybe even for your brain?
Right. Let's move past just the gym floor. We know, okay, 95% of it is stored in muscles, skeletal muscle.
Yep, the vast majority.
But that other 5%, that seems to be where we unlock this idea of its universal importance.
Precisely. That remaining bit is absolutely critical for the brain, the heart, even the retina, basically any tissue that needs energy, like right now and consistently.
This is about cellular function at a really basic level.
Yeah. When you talk about optimizing how your cells work, creatine is often right there in the middle of the conversation.
Okay, let's start with the basics then. Creatine 101. What exactly is this molecule chemically, and how does our body actually make its own?
Sure. So it's a small organic molecule, occurs naturally. Your body actually synthesizes it itself using 3 amino acids: arginine, glycine, and methionine.
Okay, and where does this synthesis happen?
Primarily in the liver, kidneys, and also the pancreas. They're churning out maybe 1 to 2 grams every day.
1 to 2 grams. And like you said, most of that heads straight for the muscles.
Right, 95%. And that small leftover amount, that's reserved for those really high-demand organs that just can't afford an energy dip. Brain, heart, eyes, even sperm cells need it.
That storage ratio really tells a story about its main job, doesn't it? Rapid energy.
Absolutely. Fast energy transfer.
So this is where it gets really interesting for me, the mechanism. We always hear about ATP. Can you break down how creatine works as this, quick charger for ATP?
Definitely. Think of ATP, adenosine triphosphate, as the universal energy currency. It's like the fully charged battery for every cell.
Okay.
When a cell does work, like a muscle contracting or nerve firing, that ATP releases energy. But in doing so, it becomes ADP, adenosine diphosphate. The battery's spent, basically.
So ATP is used up, and the cell needs power now. It can't wait for the slower energy systems to kick in.
Exactly right. And that's where creatine, or rather its stored form, phosphocreatine, PCR, comes in. When you supplement, you boost those PCR stores.
Right.
So when ADP shows up, PCR immediately donates its phosphate group back to ADP. Zap, it's instantly ATP again.
Wow, okay.
This whole reaction is managed by an enzyme called creatine kinase. It's like the traffic cop, ensuring that phosphate gets transferred super efficiently.
So it's literally the fastest energy talk-up system we have.
It is. Having more PCR means you can sustain that maximum effort, that explosive jump, the final push on a heavy lift, that first burst out of the blocks for those critical few seconds longer, usually up to about 30 seconds maybe.
Before the other systems have to take over.
Before you have to rely on, breaking down glucose and other slower processes.
That instant recharge is incredible. But speaking of getting fuel, how do we get it from food? What are the main dietary sources?
Well, creatine is found almost exclusively in animal products. If you want the highest amounts, you're looking at raw beef, maybe 4 to 5 grams per kilogram.
Raw beef.
Pork and poultry are a bit lower, maybe 3 to 4 grams per kilo. Fish like salmon or herring are in that ballpark too, around 3 grams.
And how you cook it really matters, doesn't it? If I like my steak well done, am I losing some of that creatine?
You definitely are. Heat, especially cooking it for a long time, converts some of that active creatine into creatinine.
Ah, creatinine. That's the waste product.
Exactly. It's inactive. So the amount you actually absorb from cooked meat is often less than what's in it raw.
This leads us to a really important point for a lot of people listening. The vegetarians and vegans. Since it's basically not in plants, what does that mean for someone who avoids meat?
It means a lot, actually. Studies have shown pretty clearly, like one big one back in 2003, that vegetarians and vegans tend to have significantly lower creatine levels.
Not just in muscles.
No, not just muscle, but also in the brain, and that's really critical.
So if they decide to supplement, they must experience much bigger percentage improvements compared to meat eaters.
Absolutely. They're starting from way lower baseline levels. So taking creatine often gives them a much larger boost in strength, sprintability, and sometimes even cognitive stuff like memory or fluid intelligence. It's
Interesting.
a supplement that can offer a really high return for people on plant-based diets.
Okay, so the body makes it, we can eat it,
Yeah.
but we also lose it, right? It's not like we store it forever. How does that work?
Right. It's a constant turnover. Every day, about 1 to 2% of your total creatine stores naturally break down into that waste product, creatinine.
Oh.
And then your kidneys filter that out and you excrete it in urine. So because you're always losing a bit, you need a continuous supply, either from your diet or a supplement, just to keep those stores topped up.
Makes sense. Let's talk supplements then. You walk into a store or look online, and it's overwhelming. You see creatine ethyl ester, crealkaline, hydrochloride,
Yeah.
all costing more, all claiming to be better. What's the real deal? What's the gold standard here?
Oh, yeah. The marketing is intense, but the science, it's incredibly clear on this one. Despite all those fancy, expensive forms, hundreds, literally hundreds of studies consistently show that plain old creatine monohydrate, just CM, is the gold standard.
It's just the basic stuff.
Yep. It's the most effective, it's the most researched by far, it's proven stuff, and importantly, it's the cheapest option.
So are those claims about better absorption for the expensive types just marketing fluff? Am I wasting money?
Pretty much, yeah. Major reviews, like one in the JSSN back in '07, looked at this specifically. They found zero convincing evidence that these newer forms get more creatine into your muscles than monohydrate. Yeah, and some, like ethyl ester, they actually found it was less stable, breaking down into useless creatinine faster in your stomach. So you're often paying more for something that might even be less effective.
Okay, hold on. If monohydrate is so good and cheap, why do these other forms even exist? Is there any reason someone might choose, say, creatine HCl?
The only really practical reason is if someone experiences digestive issues with monohydrate. A small number of people might get bloating or diarrhea, especially with larger doses, or if it's not mixed well.
Okay.
In those specific cases, sometimes a form like HCl, which might dissolve a bit better, could potentially help. But honestly, for most people, just making sure the monohydrate is fully dissolved or maybe splitting the dose usually solves any GI problem. Monohydrate really is the go-to.
Right, okay. So assuming we're sticking with monohydrate, let's talk dosing. The classic loading phase, everyone's heard of it. Should you do it? Fast versus slow.
Okay, so you've got two main strategies, and both get you to the same place eventually.
Yeah.
Full muscle saturation. The fast way is that loading phase. Typically 20 grams a day, but you split it up maybe 4 doses of 5 grams each for about 5 to 7 days.
And the point of that is just to saturate the muscles quicker.
Exactly. You can boost your muscle stores by around 20% in just a week. Then, after that loading week, you drop down to a maintenance dose, usually 3 to 5 grams a day.
Okay, advantage, speed, disadvantage.
Higher chance of those potential digestive issues we just talked about, just from taking more at once.
Right, so what's the alternative? The slow way.
The simpler approach, and probably better for most people, is just consistent dosing from day one. Skip the loading, just take 3 to 5 grams. I usually suggest aiming for 5 grams every single day.
Just 5 grams daily from the start.
Yeah.
How long does that take to reach the same saturation level as loading?
It takes a bit longer, maybe 3 to 4 weeks, but you end up in exactly the same place.
Okay.
The key takeaway really is consistency. Taking it daily, even on days you don't train, that's what matters most over time. It's easier, cheaper, less likely to cause stomach upset. For most people, that's the way to go.
Okay, that makes sense. But what about cycling? You always hear you need to take breaks, like cycle off creatine for a month after using it for a few months. Why is that idea so common, and is it actually necessary?
Ah, the cycling myth. It's one of the most persistent ones, and it usually comes from a slight misunderstanding of physiology.
How so?
Well, it is true that if you supplement with creatine long-term, your body does slightly reduce its own natural production. It also slightly reduces the number of creatine transporter proteins.
Right, so doesn't that mean you should cycle if your body stops making as much?
Not necessarily, because that reduction, that downregulation, it's not a bad thing. It's a normal physiological adaptation. Your body's just being smart, conserving energy because it sees you're getting plenty from an external source.
Or it's reversible.
Totally reversible. And crucially, the high levels of creatine inside your muscle cells, the stuff that actually powers performance, they stay high as long as you keep supplementing.
So no need to cycle off. Continuous daily use is okay.
The scientific consensus is clear. Yes, continuous daily supplementation of 3 to 5 grams is safe and effective long-term for healthy people. If you stop, sure, your natural production ramps back up, but those performance benefits will gradually fade as your muscle stores decrease over weeks.
Okay, good to clear that up. Let's shift to the benefits then. Where does creatine really make a difference? Which activities benefit most from that rapid energy system boost?
It absolutely shines in anything explosive, high intensity, and relatively short duration. Think powerlifting, heavy weightlifting sets, sprinting, jumping, plyometric.
Team sports too, like quick bursts.
Definitely. Any sport involving repeated high-intensity efforts with short rests, think soccer, basketball, hockey, track sprints, that's where the PCR system is king.
And are the results noticeable? Or is it just marginal gains for elite athletes?
No, these are significant gains that most people will feel. We're talking meta-analyses showing average strength increases like your 1 rep max, often in the range of 5 to 15%.
That's substantial.
It is. And for things like repeated sprints, you can see performance boosts up to 15% too. Basically, it lets you train harder, do more reps, sprint faster or more often, and recover quicker between those intense bouts. That adds up over time.
Now, connected to that performance boost is the weight gain question. People say creatine just makes me bloated with water. Is that accurate? Is it just useless water weight?
Okay, the initial weight gain is real. Creatine is osmotically active, meaning it pulls water into the muscle cell along with it. So yeah, gaining maybe up to a kilogram, perhaps a couple of pounds in the first week or two is pretty common.
But it's not just puffiness.
No, and this is the really important distinction. That cell swelling, it's called cell volumization, isn't just dead weight. It actually seems to act as an anabolic signal, meaning a more hydrated cell is metabolically more active, it's more resistant to breaking down, and it seems to create an environment that's better for muscle growth, for protein synthesis in response to training. So the weight you gain long term is a combination of that functional water that's actually helping the cell work better, plus actual lean muscle tissue you've built because you were able to train harder and recover better thanks to the creatine.
That makes a lot more sense. What about endurance athletes then? Marathon runners, long-distance cyclists. Does the weight gain work against them, especially if they're watching their power-to-weight ratio or VO2 max?
That's a really relevant question for them. For pure, steady-state aerobic endurance, creatine itself doesn't have much of a direct impact on something like VO2 max.
Right.
And yes, that initial water weight gain could slightly decrease their relative VO2 max, the measurement per kilogram of body weight. For an elite endurance athlete where tiny percentages matter, that's a calculation they have to make.
So maybe not for the pros focused purely on endurance. But could there still be benefits, maybe indirect ones, for recreational endurance folks?
Oh, absolutely. Think about the parts of endurance sports that aren't steady state. Launching an attack on a climb in cycling, the final kick in a race.
The high-intensity bits.
Exactly. Creatine can significantly boost performance in those anaerobic moments. Plus, it can really help with recovery between hard training sessions, which is huge for endurance athletes piling on mileage.
Any other potential benefits?
There's also some interesting, though less conclusive research suggesting it might help with thermoregulation and hydration, especially when exercising in the heat. So yeah, while it might not be the first supplement an endurance athlete reaches for, recreational runners or cyclists could definitely see benefits. Elites need to weigh the pros and cons carefully.
Let's tackle the safety concerns head on. Because despite all this positive data, you still hear the big two: kidney damage and hair loss. What's the scientific consensus on safety?
Look, the safety profile of creatine monohydrate is incredibly well established. Major reviews and position stands, like those from the International Society of Sports Nutrition, ISSN, consistently state that creatine, at the recommended doses, is safe for long-term use in healthy individuals. It's genuinely one of the safest supplements out there.
Okay, but the kidney fear persists. Why is that? Where does it come from?
It almost always stems from confusing creatine, the supplement, with creatinine, the waste product.
Right, we talked about that earlier.
Yeah. When you take creatine, especially if you load, your blood creatinine levels might go up slightly. But this isn't a sign your kidneys are failing. It just reflects that you've got more creatine breaking down because you're taking more in. Healthy kidneys are perfectly capable of filtering out that slightly increased amount of waste. It doesn't indicate damage.
So, unless you have pre-existing kidney issues.
Exactly. That's the crucial caveat. Anyone with known kidney disease absolutely must talk to their doctor before considering creatine. But for healthy people, the fear is largely unfounded.
Okay, what about the hair loss connection? the DHT link. That seems to worry a lot of guys.
Right. This one traces back mainly to a single, relatively small study from 2009. That study suggested that creatine supplementation might increase levels of DHT, dihydrotestosterone, which is a hormone linked to male pattern baldness. But here's the thing. That finding hasn't been consistently replicated in later studies. There have been quite a few looking at hormones since then, and they haven't found the same effect on DHT. We just don't have strong, repeated evidence showing creatine directly causes hair loss.
So the link is tenuous at best.
Very tenuous. The scientific consensus right now is that it's highly unlikely to be a cause of hair loss for most people.
And the absolute worst fear-mongering any link to cancer.
Zero. Absolutely no scientific support for that whatsoever. If anything, because of its role in cell energy and potentially protecting against certain types of cellular stress, some very early research is looking at potential protective roles, but that's highly speculative right now. The main point is no link to causing cancer.
Okay, so summarizing this whole deep dive then, we've kind of taken creatine from just being this gym supplement to something much more fundamental. What are the absolute key takeaways for someone listening?
I'd say, first, creatine monohydrate is king. It's proven effective, safe, and cheap. Don't waste money on fancy versions unless you have specific GI issues with monohydrate.
Got it. Monohydrate.
Second, dosing is simple. 3 to 5 grams a day, every day. Consistency beats loading for most people.
Daily habit.
Third, forget cycling. It's not necessary. Continuous use is fine. Fourth, the weight gain is mostly functional water initially, helping performance, and later includes real muscle gain. It's not just bloat.
Okay, and safety.
Fifth, safety concerns about kidneys and hair loss are largely unfounded based on current science for healthy individuals. Talk to your doctor if you have pre-existing conditions, especially kidney disease.
Right, that clarifies a lot. It really makes you think, though, if creatine is so vital for energy in tissues like the brain and the heart, not just muscles, what else might it be doing? What potential benefits are we only just starting to uncover?
That's exactly where the research is heading now, and it's really exciting. Scientists are looking seriously at creatine's role in mitigating some effects of aging.
Like cognitive decline.
Potentially, yeah. And it's possible therapeutic uses in neurodegenerative conditions, think Alzheimer's, Parkinson's disease. Also, potentially as an add-on therapy for depression and for boosting cognitive function generally, especially maybe when you're sleep deprived or under stress.
Wow. So it could move from being seen just as a performance enhancer
To potentially being viewed as an essential nutrient almost for maintaining overall vitality, brain health, and maybe even contributing to longevity down the line.
a fundamental molecule for health, not just for workouts.
It's a really powerful shift in perspective, moving it from the sports aisle maybe closer to the vitamin shelf, conceptually.
Well, hopefully this deep dive is giving you a much clearer science-backed picture of this incredibly useful and safe molecule. Thanks for exploring creatine with us today.